evening everyone. Welcome back to the session on fundamentals of computers. Yesterday we were discussing about the different computer networks, the introduction to it, and also the various topologies that are available. So we all now know what a network is and what are the different network topologies we have. We have the star network topology, ring network topology, mesh network topology, and hybrid network topology. They are the different topologies we have. And then we were talking about the network types, LAN, WAN, MAN, what are these and how are they having their own properties. And then we were talking about the communication protocols, the roles of the communication protocols. After that we were discussing about network interface cards, how important network interface cards are, and what does this hardware give to us, like what role is the network interface card playing while connecting to the internet, as these are the medium which is helping the computer to connect with the cable that is coming over the internet. Okay. So then we were seeing about the most important concept, that is the OSI model. Every OSI model has 7 layers, and these 7 layers are built inside the operating system software, and all the operating system softwares provide this kind of a model so that it becomes a standard practice and any network is able to connect to any other computer network. Okay. So these are the 7 layers that we have. And then we were talking about the physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. And then we started with internetworking. What do you mean by internetworking? Connecting 2 or more different kinds of networks together to form a single network is called internetworking. Okay. And the best example for internetworking is the internet. Internet is the best example for an internetworking. And then we started with internet. What do you mean by internet? The internet is a network of computers that links many different types of computers over the world. We were discussing about when did it evolve and whatever the different websites that we had in the initial days. We only had around 4 sites in 1969 that were interconnecting computers, and then now we have like lakhs of websites available on the internet. And then in 1989, how did the US government lifted the restrictions, and then how did it all start into the commercial purposes? That is all we discussed. And then we started with the basic services of the internet. What are the basic services of internet? Initially we had, nowadays we know we can tell so many applications and so many services that the internet provides in these days, but in the earlier days it was only the basic electronic mail, FTK, file transfer protocol, FTP, telnet, usenet, news. These are the main use of internet. And then we started with the internet representation. How is the internet connected? When there are 2 computers in 2 different places, then the internet is connecting those 2 computers. Whereas one thing you have to understand here is, suppose this is our computer, then this might not be the same computer which is having monitor, CPU, keyboard, everything, but this might be something like a supercomputer or a server which is only giving us the data that is required. So for the basic understanding, just try to understand these 2 are 2 different computers with the internet connected between them. But computers not only monitor, CPU and all, but it has various kinds of computers like servers and all. So we'll see them all in the next slides. But as of now, internet address means it is a global network of computers, and each computer connected to the internet has a unique address. The internet address or the IP you call it has a unique formatted address which should be in between 0 to 255, and generally IP stands for internet protocol. Okay, we discussed about all this yesterday. And then the protocol stacks and the packets, what are they, and what are the different protocol layers we have and what do they do. Okay. And after that we were discussing about how when the application is sending some data to the other computer, how is it transferred through the internet, and how is it going back to the other computer. Okay. And then so we'll just try to look at this diagram once again today, and I'll list out the different points that are happening or the different steps that happen in this diagram. So the first thing is the message would start at the top of the protocol stack at the computer and work its way down. So it's all starting at the protocol stack here, and it's making its way down the message. Okay. If the message to be sent is long, each stack layer that the message passes through may break the message up into smaller chunks of data. This is because data sent over the internet and most computer networks are sent in manageable chunks. Yesterday I was telling you, right, if you have a 1 MB file, the 1 MB file is divided into small chunks, that is packets, and the data is sent in packets to the other computer with the ID number of that computer. What is the ID number of the other computer? That is the IP address that we were discussing. So on the internet, these chunks of data are known as packets. We all know, we all understood what packets are now. And if the message that needs to be sent is really long, then, or it is too long for that computer to handle in that network, then it will each stack layer that the message passes through, these are known as the stacks, and each stack layer that the message is passing through, it will be break down into small chunks of data. Okay. And then the packets would go through the application layer and continue to TCP layer. Each packet is assigned a port number. So when the packets are started moving downwards in this stack, in this protocol stack, they'll first get divided into small chunks of data, that is packets, and once it reaches the TCP layer, at that point they are assigned a port number. What do you mean by port number? There are different ports in your computer which are connected to the internet. Okay. So each packet is assigned a port number, and then we need to know which program on the destination computer needs to receive the message, because it will be listening on a specific port. As I told you, on the computer you have different ports. Every application will be using different ports that are available on that computer with the help of internet. Like, only a port is assigned to the website or the application when it is connected to the internet. Okay. When that particular application is connected to the internet, then that application is assigned a port number, and on that port number or on that specific port, the application will be listening to the data. Like, if it will be searching for the data that it needs to get. Okay. So the packets would go through the application layer down and continue to the TCP layer. At that point, each packet is assigned a port number. So there are several ports, as we discussed, and the application will be listening on a particular port. We need to know the program on the destination computer that needs to receive the message, because it will be listening on a specific port. Okay. And then after going through the TCP layer, the packets proceed to the IP layer. What do you mean by the IP layer? The internet protocol layer. This is where each packet receives the destination address. So in our example, this is our computer 1234 and the other computer is 5678. Now, like, the IP address of the first computer is 1.2.3.4. the next computer's IP address is 5.6.7.8. Now, if I am sending a 1 MB file from here, that 1 MB file is divided into 10 chunks of data, or 10 packets. Each packet is 10 KB. So when it is sent down, it will first identify for the port number. It will be assigned the port number, each packet, and then it will search for the port number of this application. Okay. When it's going down, then it will be assigned an IP address. What is the IP address that these chunks of data are assigned? They are assigned the IP address of this computer. What is the IP address of this computer? 5.6.7.8. Now, each chunk of data or each packet on this that is being transferred is assigned the same 5.6.7.8. The reason is, whatever packet is going through this network for this computer, it has to reach, all the packets should reach only this destination. That means every packet should have the same ID number or the IP number, that is 5.6.7.8. And then, now that our message packet have a port number and an IP address, they are ready to be sent over the internet. The hardware layer takes care of turning out packets containing the alphabetic text of our message into electronic signals and transmitting over the phone line. Now, what is happening in this diagram? Initially, we had that 1 MB file that we want to send from this computer to this computer over the internet. Then that 1 MB file is divided into chunks of data, that is known as packets. These packets are sent to the TCP layer next. The TCP layer identifies on which port this application is listening and which port number has to be assigned to these packets, and then it is transferred to the IP layer. In the IP layer, each packet that is being sent over the internet is assigned the same IP number of this of the other computer, so that all the packets will be only reaching that particular computer. And then when it is assigned the IP number and also the port number for this computer, then it will go to the hardware. In the hardware, what do we have? We have those network interface cards we saw in the previous thing, right? The NIC. Okay, what do you mean by NIC? Network interface cards. I'll show you once again. Where is it? These are the network interface cards we were talking about. You remember this slide, right? These network interface cards, they'll help us to connect and transfer the data that is required for us on that network. Now, once we have received the IP address of this computer and the port on which their computer is listening, and each packet is assigned the port number and the IP address, then it will go to the hardware. In the hardware, we are sending the text in English form, but that is not the way it is transmitted over the network, right? It will be transmitted in electronic signals. So this hardware layer converts all those all the English text or the plain text that we understand into the electronic signal form, and it transmits it over the internet. When it is transmitted to the internet, through the internet, again it is reached at the hardware layer. It doesn't reach the application layer directly. From this hardware layer, it is converted into the electronic signals. From these electronic signals, it is again sent to this hardware layer. This hardware layer in turn will convert those electronic signals back into the text, or each packet is again converted into a human readable or user form, and then this IP is the IP address that is assigned to this. It is opened up and it will go to the application layer. Okay, so that is how it happens. Now, okay, and then we all saw this, right? And then after going through the TCP layer, okay, this is all done. Just a minute. Okay, and then what happens on the other end of the phone line? Your ISP has a direct connection to the internet. We'll see what ISPs are. Yesterday I was discussing about ISPs, internet service providers. They have their own router, right? Your signal towers and all. Those signal towers are in turn again connected to their routers. The ISP router examines the destination address in each packet and determines where to send it. After the packet's next stop is another router. We'll see on the routers later. Then eventually the packets reach computers 5.6.7.8. Here the packet start at the bottom of the destination TCP IP stack and work upwards. That is what we were seeing. It is in between in the internet. This is just to show you that there is internet, but in the internet you'll have again the routers, modems and all. Once it and you'll have all the internet service providers in between. After it crosses all the stages, it will goes to the hardware of this other computer. Okay, once it reaches the hardware of the other computer, as the packets go upwards through the stack, all routing data that the sending computer stack added, such as IP address, port number, is stripped off from the packets. That means, now what is happening? Initially we only had that 10 MB file. Initially we had only that 1 MB file. That 1 MB file is again divided into small chunks, that is called packets. These packets are then traveling through the TCP, and in the TCP what is happening? It is assigning a port number that this application is listening, and when it goes to the IP layer or the IP stack, at the IP stack it is assigning each packet. We have 10 packets of 10 KB each, that for that 1 MB file. So for each 10 KB file, it is assigning the same IP address to those packets, so that all the packets will safely reach the destination address. Okay, and then when it's going to the hardware layer, it is converting those into electronic signals, and when it's going here through the internet, at the hardware layer, it will convert this electronic signals back into the text. When it's converted into the text, it goes to the IP, and in the IP it is again removing the IP addresses that is assigned to each packet, because it doesn't require now as it has reached the address. Then in the TCP, whatever port number is assigned to the each packet, it is removed, and then only the application that is required at the application layer, all the small chunks are added together, and the user gets the 1 MB file as a single file. Okay. So where were we? Okay, just a minute. Okay, fine. So what were we discussing? We were discussing about, there was a network issue, I guess. So we were discussing about the application that is being transmitted from one computer to the other. Now what is happening, I will discuss it once again in 1 minute. So we have a 1 MB file that is divided into chunks of small sizes, that is 10 KB each, and it is sent over the application layer. When it's sent over the application layer, the TCP layer, it identifies the listening port where that application is, and it will assign that port number to these small chunks of data, that is packets. And then in the IP address, in the network, the IP address identifies what is the IP address of this computer, and for each packet it will give the IP address of this other computer, that is each packet in this network will get the IP address 5.6.7.8. Then it is going to the hardware layer. Over here in the hardware layer, it's converting that whatever data into electronic text, and in the electronic text, it's going through the internet, and here in the hardware layer again it's converting that back to the human readable form, that is English text, and it will go up. When it's going up into the IP stack, in this IP stack what happens is, now each packet is having the IP address of this computer, so it will start leaving out the IP address, because it only has to send the data file to the user. So in the IP stack, whatever each packet is having the IP address, that is removed, and in the TCP layer or the TCP stack, whatever port number is assigned to each packet, that is also removed, and only the packets that are divided, they are sent into the application layer. At the application layer, again all the packets are rejoined together, and the final 1 MB file is sent to the user at the other computer. Okay, this is how data is being transmitted over the internet. And then okay, now that is about how that diagram is working and how data is being transmitted from one computer to the other in the internet. Next we have interconnecting infrastructure. Yesterday we were seeing about this, right? So whatever is happening between these two computers, we just denoted with the diagram of internet here. We were just denoting with one internet rectangle over here between these two computers, but when you see in the real life, or when you see practically, that small internet rectangle box is having these many connections, and this is also very simplified diagrammatic representation. When you even go into each component, then there will be so many other components that you will be able to see, but try to just understand this much, where your computer is connected to a modem. We know that modem is having a public telephone network, or your whatever network that you are using, that network it is connected to, and this network has a modem pool. This modem pool has all the IP address or whatever lines it is having, whatever connections are connected to this modem pool, all the users data is available in this modem pool. From this modem pool there will be an ISP port server to which it is connected, and that ISP port server is connected to the router again. All these routers are connected to each other on this ISP backbone, and the data is identified by this router and it starts going to this another computer. We will see what it is, how it is now, where before going to that you have to understand the application protocols HTTP and the World Wide Web www. If you understand these concepts, then you will be able to have a very clear idea about these ISP concept. Okay, ISP and the internet concept you will be able to understand. So let us see what this World Wide Web is. Okay, one of the most commonly used services on the internet is the World Wide Web, www. whatever address that you give, that is World Wide Web. Okay, the application protocol that makes the World Web work is hypertext protocol. Okay, hypertext transfer protocol, that is HTTP. Okay, HTTP is the protocol that web browsers and web servers use to communicate with each other over the internet. It is an application level protocol because it sits on the top of the TCP layer in the protocol stack and is used by specific applications to talk to one another. In this case, the applications are web browsers and web servers. Okay, so what is happening here? This HTTP, it is a protocol, that is hypertext transfer protocol. It is above the TCP layer, in the application layer you can call it, where what is it doing? It is an application level protocol that just sits on the top of TCP layer in the protocol stack. We all know that because in the application layer you have this HTTP and it is used by specific applications to talk to one another. Now when you are trying to connect to a website or when you are trying to connect to the internet, how are you doing it? You are only able to open a browser and then trying to connect to the internet. So whatever we are doing, it's all in the web browser application. So the application layer has the components that are required for that web browser. Over there in the web browser we are using HTTP, that is HTTP a colon and then 2 forward slashes followed by the address www. whatever is the address that you want to type in. So where is this HTTP? HTTP is in the application layer on the top. When you type something in the HTTP application layer, then it sends a request to the TCP layer, and in the TCP IP layer what is happening? It's fetching for that address, where number and where is that computer located, and from there it is sending the signals to the hardware, and the hardware is converting that www.google.com or whatever it is into the electronic signals, and it's transmitting that request over the line in the internet. When it's going to the other side where it has the data related to that www.google.com, it is picking up data and it's sending it back to the user with the request. Okay, so next we will see what routers and packet switches are. A router is usually connected between networks to route packets between them. Now we all know what packets are, and over here when you see this diagram you are able to see routers. So we have to understand first what routers are in this diagram and what are these servers and modem pools. If you understand that, you will understand how is this all happening. Okay, so let's see first what routers are. A router is usually connected between networks to route packets between them. Now in the previous block diagram where we had 2 computers and the internet which is connected between them, we were dividing that 1 MB file into small packets and we are sending it. Now how are we able to send it to the other computer, and how are we able to reach the destination properly? It is through this routing. A router is used usually which is connected between the networks, and it will send the packets that are required in the destination point. Okay, I will show you, just a minute. Now just a minute. Now I was talking about the router, right? A router is usually connected between networks to route packets between them. So we will see what that means. Now what is happening here? Here we are trying to send some data from your computer, from my computer to another computer. At this point, what is happening? We are transmitting it over the internet. When we are trying to send those packets of data through the internet, the router identifies to which other router those packets have to go, and it doesn't let the packets reach some other router that is in between, and it will help us in routing the packets, that is making its path to the router that we want, and this router will identify the data that it has to receive, and it will take the request, and it will let the data in. Okay. So that is the concept of routers. Each router knows about its subnetworks and which IP addresses they use. The router usually doesn't know what IP addresses are above it. Okay. The black boxes connecting the backbones are routers. The larger NSP backbones at the top are connected to an NAP. We will see what NAP is, what NSPs are. Yesterday in the picture I showed you what they are all. Now we will discuss about them. Under them there are several subnetworks, and under them more subnetworks. At the bottom are two local area networks with computers attached. So this is the diagram that yesterday that we were discussing, and the black boxes connecting to the backbones are routers. The larger NSP backbones at the top are connected at a NAP. So what are these NAPs? They are your network access points. What are these NSPs? They are your network service providers. And what are these ISPs? These are internet service providers. And you have regional internet service providers, local internet service providers. Okay. And these MAEs are metropolitan area exchanges. We will see what all these are, and then you will be able to understand who all are managing the internet and how are we able to get connected to the internet. We all know only about the service providers that we have, that is Airtel, Jio, BSNL, whatever network you are using, Idea, Vodafone. These are the networks that we know. But are these the only people who are managing the internet? No, that is not the answer, because there are so many other players who are there in the internet who are managing it and who are providing the services. The network providers that we have, the Airtel, Jio, these people are only up to at max they will be able to fit in this level itself. Other than that, on the top of that, they won't be able to have their hand above it. Okay. So you may have regional service providers, regional internet service providers as your Airtel, Jio and all, but or otherwise at the local level, at the local internet service provider level itself. Above that, they are connected to some other network service providers who have a much higher hand than what they are having. They are the ones who are controlling the internet, and on top of them we have the network access points and the metropolitan area exchanges. Each network service provider is connected to at least two or more network access points. Okay. These network access points, they are connected to these network service providers and the metropolitan area exchanges. Now this is all a very generalized diagram, but internally when you see this local ISP, you will be able to have so many connections internally for it. But if you want to have an understanding, the main ones are your network service providers, from which we are having the regional internet service providers, and from the internet service providers we are having the local service providers. So when you now read these, you will be able to understand that under them there are several subnetworks, and under them more subnetworks. Okay. At the bottom are two local area networks with computers attached. Under this local ISP, we will have the LAN, that is local area network, with the computers connected to them. Okay. So this is the basic idea of the internet infrastructure. And then if you want to see the internet routing hierarchy, it looks like this, where you have this NSP. Now you understood what this NSP is. It's the network service providers. These network service providers are giving you the routers, and this router is then connected to the regional internet service providers. These regional internet service providers are then connected to the local internet service providers, and from where you are getting your local area network to these computers that are connected. Okay. And then when you type a URL in the web browsers, what is it that happens? We are going to discuss this, and you will understand what will happen when you type something in the web browser. When you are typing something in the web browser, that is known as a URL, that is Uniform Resource Locator. Okay. Now The www is known as World Wide Web, that is www.google.com. The whole thing that is there, that is known as your URL. That means you are giving it a name so that that name has a DNS address at the back of it, and that DNS address is able to, like, we are able to search with that help of DNS address the data that we want for that google.com. Yeah. So first we will try to see when you type a URL into a web browser, what happens. If the URL contains a domain name, what do you mean by domain name? The google.com is the domain name. Like that we have so many websites and they all have their own domain names. So if the URL contains a domain name, the browser first connects to a domain name server and retrieves the corresponding IP address of that server. I told you, right? First of all, whenever we are typing something like www.google.com, it will first go back and check if it has a domain name server, like if it has a number or an ID. For that you can just call it like an ID, but because as of now it's all basic that we are discussing. Just like the IP, the internet website that is there, that will also have a number. So this number is first searched in the domain name server. In the server is just a computer in which it will try to find that number. Once it finds that number, it will try to find the corresponding IP address for that web server. Now that number will be connected to some other web server or the other computer. That computer also has IP address, right? So it will first try to find out the IP address with the help of this DNS or the domain name server application. Then the web server connects to the web server, and the web browser connects to the web server and connects to and sends a HTTP request via the protocol stack for the desired web page. Where is the HTTP request? It is after the application layer. In the TCP layer it is having this, and in the application layer you have the HTTP, that is then sending the request in the TCP, that is the protocol stack, for the desired web page. The web server receives the request and checks for the desired page. If the page exists, the web server sends it. If the server cannot find the requested page, it will send a HTTP 404 error message. 404 means page not found, and as anyone who has served the web probably knows. Okay. The web browser receives the page back and connection is closed. Whenever you receive the request or whenever you receive the data that is required, at that point the connection is closed. And then the browser then passes through the page and looks for other elements it needs to complete the web page. These usually include images, applets, etc. We have so many other things that are loaded, or there are so many other functionalities that our web pages have. First of all, only the data that is required or the connection is established, and then once all the data is received, from that data it will start loading whatever it requires. For each element needed, the browser makes additional connections and HTTP requests to serve for each element. Okay. The browser will make additional connections whatever is related. Suppose there is one web page and it has several other connections behind it. Then first this connection is loaded, and through that connection there are several other requests which will load the other connections or the other pages on that website also. When the browser has finished loading all images, applets, etc., the page will be completely loaded in the browser window. When you just try to see that browser page with that reload button, whenever you are entering something and you are trying to search something, it will first give you an into mark there which is still loading the web page. So once the complete web page is loaded, you will be able to see a refresh button over there. So that means the web page is totally loaded. So we will see how this is happening in the web browser, and then you will have a better understanding of what it is. Okay. So I am opening the web browser. The Microsoft Edge is also a web browser, and you have so many other web browsers. I asked you to search for them on the internet, and I gave you as an activity. So fine. So I am trying to open a web browser now. When I try to open the web browser, this is the default page that is there, and it all depends upon what all different each different web browser has its own web page. Okay. So initially this is where I will be searching for my website address. Search or enter web address is mentioned here. This is where I will type my URL. What is the URL? That is www.google.com or whatever is the address that you want to type. So first of all, when I am typing www. It's giving me some suggestions. You can type anything that you want. So I am typing in google.com. At this point, whatever is this is your World Wide Web. That means you are first connecting to the World Wide Web server or the computer, and in that computer you have all the information related to all the pages that is connected with www. Okay. So when you are connecting to this computer and then to this website is again connected to its own web server where you have all the data related to the google.com. Okay. So first I will type this web server, this URL, and I will enter. When I am typing enter, you are able to see a cross mark over here. That means it is sending the connection request. This is the web browser. So this is the application layer of our protocol stack. When we type something here and we type enter, it is sending a request to the TCP layer and then the IP layer and to the network layer. It's transmitting over the internet, and on the other side where we have our network or the Google server, from there it is retrieving the data and it's getting back and it's loading the page. Once it loads all the contents, you are able to see it's complete. Once it's complete, you will see this logo which is refresh, or if I am trying to again reload it, you are able to see a into mark where it's trying to load the page. And once I loaded it, even though if I don't give this HTTPS connection request, but still it automatically assigns this request, like it is automatically assigning this. The reason is, in the application layer we have this HTTP protocol. Okay. So whatever data that is being sent through this application layer, it is automatically having the HTTP protocol. That is the reason it is automatically being assigned. And then the next thing that you have to know is, this is the search engine. Yesterday we were talking about the search engines, right? So in the browser, what are the different features that we have? Whatever we download will be there in the download section, and whatever you search will be there in the history section, and you can have different customizations that you want for this browser. You can open multiple web pages by using different tabs. This is all about the browsers. Okay. So we all understood now how this web browser, what this web browser is, what does this web page contain, or how is it making the connection request with the internet, where is it going, how is it fetching, and all we have seen. So with this, the second unit is complete, and in the second unit we have discussed mostly about the network topologies, what a network is, what internet is, and what are the different kinds of topologies we have. Along with that, we were discussing about what does the internet, what do you mean by the internet, and also the different types of network types we have, LAN, WAN, MAN. And after that, we spoke about network interface cards, the OSI model, what are the different layers in the OSI model, and what is internet working and internet, when did it all start, and what are the basic services of the internet. And we then saw how the internet is connected with the IP addresses, and what do you mean by TCP protocol and the internet protocol layers. How is data being sent from one computer to other, and what are the different devices that are there in between the two computers that are being connected on the internet. And also we saw what do you mean by World Wide Web and HTTPS, HTTP and HTTPS. And then we saw what are routers, packet switches. After that, we discussed about the internet infrastructure, where what is the role of the ISP, internet service provider, at the local level, and who is managing at the top. We have seen all of that. And then the internet routing hierarchy. After that, when you type a URL in the web browser, what happens? We have discussed about that. And with that, we have come to the end of the second unit. Okay. In the next class, we will start with the third unit, which is all about printers, how, and all. We'll be starting with the output units, output devices, what are the different printers we have, how do we connect printers and all. So if you have any other doubts, you can just post it in the Q&A section. And so that's it for today. Thank you. Okay, there is a question like, so what's the difference between NSP and ISP? Okay, where is this? I'll show you, just a minute. Just a minute, guys. I'll try to explain you the difference between NSP and ISPs, and then we can close this session. Okay, so as I discussed previously, wait a minute. As I discussed previously, we have this ISP, that is the internet service provider for us. Okay, what do you mean by ISP? First of all, ISP means internet service provider. Okay, internet service providers are in multiple ways. First of all, at the user level, for us, Airtel, Jio, Idea, whatever is there, they are all the internet service providers for us. But for these ISPs, that is the local ISPs also have one more internet service provider, right? That is the regional service provider. The regional service ISPs are providing internet to the local ISPs, and these local ISPs are sending it to us. But where are the regional ISPs getting the internet connections from, or the internet services? They are getting the internet services from the network service providers. Who are the network service providers there? You can see the examples here: SurfNet, UUNet, PSINet. We don't even know what those companies are generally, because we only think that the internet is provided only by the local ISPs, that are Airtel, Idea and all. But if you see in the bigger picture, the internet is being provided to those Airtel, Idea, Vodafone by some other regional ISPs or the network service providers. Just try to find out on the internet what is SurfNet, who is SurfNet, who is UUNet, who is PSINet. These are the different network service providers at the very high level, who have who lay the cables down on the over the oceans, and who maintain so much infrastructure for the connectivity of the internet and all. So from these network service providers, these regional internet service providers buy that bandwidth, how much ever they want, and from the ISP, regional ISPs, the local ISPs will buy that bandwidth again. So initially there are some big companies that are laying the cables and maintaining the infrastructure to connect all the computers that are there in this world. And those computers are not only individual computers, but big servers, in which we have all the data related to Google, Facebook. Each of them maintains their own servers, and these servers are all again connected all over the world by the help of these network service providers with the network access points and metropolitan area exchanges. Okay. Now, as they are maintaining so much, and they have so much they put in so much amount into this infrastructure, or they put in so much effort into that, so they will be selling the bandwidths to the regional ISPs, so that these regional ISPs can sell the bandwidth to the local ISPs. So that is how these happen. All of them are internet service providers, but at the local level it will be local internet service provider, at the regional level it will be the regional service provider. The local ISPs are the service providers for us, and for the local ISPs it's the regional ISPs. For the regional ISPs it's the network service providers who is providing the internet. Okay. I hope you understood this doubt, and if you have any other doubt, you can just post it in the Q&A section. I will try to answer them. Okay, so I guess that's the only doubt we have for today. Okay, then we'll close it. Okay then, thank you for today. Thank you for the session.